There is a persistent misconception across the enterprise that prompt engineering is a technical skill, a form of coding meant strictly for developers and IT specialists. But a large language model is not a piece of traditional software. It operates much more like a highly capable, yet strictly literal, consultant. This chart details the prompt quality spectrum. When an executive inputs a vague one-sentence directive, like asking the model to write something about a product, and receives generic, unusable filler in return, the instinct is to blame the tool. The model executes instructions with literal precision, making the quality of the output a direct reflection of the briefing's clarity. Treating a language model like a standard software interface leads to poor results. High-value output requires the exact same rigorous briefing discipline that an executive applies when directing a human subordinate. To understand why precise framing matters, we have to look at the mechanical difference between a large language model and a traditional corporate search engine. Traditional search engines are passive systems. Typing a keyword locates an existing static document in a database. Language models, however, actively generate text based on contextual probability. The words in your prompt act as mathematical weights, determining which branches of the neural network activate. Altering the structural framing of your directive dictates exactly which sector of the model's capacity gets engaged to formulate the response. Looking at the spectrum chart again, compare a vague request to a structured directive. The density and specificity of the input on the right forces a more sophisticated, highly relevant output. Adding strict structure provides the parameters needed to activate more sophisticated statistical pathways within the model's existing capacity. Your ability to extract actionable business intelligence from these systems is directly bound to your ability to structurally engineer the statistical probability of the response. A well-constructed prompt acts as a systematic filter. It strips away generic, high-probability filler to force a highly specific, low-probability outcome. This table outlines a 5-part anatomical framework required to build an effective executive directive. The first element is role. Assigning a specific expert persona, like a senior strategy consultant, instantly alters the model's vocabulary, assumptions, and analytical framework. Leaving this unassigned forces the model to default to a generalized assistant, diluting its analysis. Next is context. A critical rule is that the AI assumes nothing about your organization's current situation. You must explicitly provide the background. Flooding the model with constraints, recent actions, and known variables directly correlates with the relevance of the advice received. The third element is the task. Directing the model requires precise, action-oriented verbs. Telling the AI to identify specific risks forces a sharper output than asking it to discuss a topic. Precision in your task verb eliminates ambiguity, preventing wasted computational cycles. The fourth element involves establishing limits. This is a defensive necessity where you define resource boundaries, explicit exclusions, and fixed assumptions. Stating what you do not want to see prevents analytical drift and saves you from reviewing arguments you have already discarded. The final element is format. By dictating the exact structural layout, like a numbered list with one-sentence rationales, you control how the information is delivered. Specifying the format up front ensures the text is immediately usable, eliminating downstream editing and reformatting work. While simple tasks may not require all 5 parameters, understanding this anatomy allows you to quickly diagnose exactly why a previous output failed. Notice that this 5-part structure is virtually identical to the standard briefing given to a highly capable human consultant before a major project. Utilizing this rigorous structural framework is the only reliable method to force deterministic, highly specialized business intelligence out of a probabilistic model. Even with a structured prompt, the most common operational error is treating the first AI response as a finished, final deliverable. A language model is not a database query. The interaction should be managed as an ongoing, fluid dialogue. The initial prompt establishes your base context and task. You then use subsequent prompts to refine the approach, redirect the focus, and deepen the analysis. You can actively push back against the model, challenge its underlying assumptions, request a deeper dive on a single point, or aggressively correct its direction. This iterative workflow carries a unique economic advantage. Probing, expanding, and requesting alternatives from a language model carries essentially 0 marginal cost and 0 friction. You can complete multiple cycles of analytical refinement in minutes, a process that would take days of back-and-forth communication with a human team. The highest value executive outputs are never generated in a single click. They are actively sculpted through successive rounds of focused feedback. Once the baseline formatting is mastered, executives can apply advanced structural techniques to scale their analytical capabilities. The first technique is few-shot prompting. By providing explicit examples of past successful documents, you force the model to flawlessly mimic your organization's specific corporate house style and tone. Next is the chain of thought technique, a strict requirement for any multi-step strategic problem. Demanding the model explicitly map out its reasoning step by step makes the underlying logic auditable. This allows you to verify the analytical path and prevents hallucinations in complex decision trees. For risk management, executives employ perspective-taking and red teaming. This diagram illustrates a stress test mechanism. Forcing the model to adopt an adversarial viewpoint or analyze a proposal from multiple distinct stakeholder perspectives reliably surfaces hidden vulnerabilities you might otherwise miss. Implementing these advanced structural techniques transforms the language model from a simple drafting utility into a comprehensive adversarial strategic sparring partner. Yet, regardless of the techniques applied, prompt engineering remains incomplete without the application of human editorial judgment. Editorial judgment is the calibrated, practiced ability to rapidly evaluate AI outputs, knowing exactly what to accept as valid, what requires heavy revision, and what must be discarded entirely. Executives must learn to spot the distinct markers of low-quality AI work, the overuse of hedging language, suspicious specificity regarding data points, and a structural formulaic glyphs that lacks real operational insight. You contrast those failures with the markers of a highly successful synthesis, moments when the system surfaces a structural consideration you genuinely missed, or accurately condenses a massive regulatory document in seconds. This defines the ideal collaborative mental model between the executive and the machine for the modern enterprise. The AI's specific domain is executing tasks that require massive breadth, computational speed, and structural formulation. The executive's domain remains applying final editorial judgment, overlaying contextual nuance, and providing the genuine situational expertise that a statistical model simply cannot possess.